Do you want to build a production-ready agentic workflow in WhatsApp? Then this is the video for you. I'm going to explain you how I integrated my agent to the Meta Developers API for WhatsApp. My agent is able to communicate with users and also retrieve information from different databases, SQL databases and also vector store databases. And on top of that, the agent has memory, meaning that it can remember the past interactions with the users, so it can provide more accurate responses based on the contextual information. And it also has a layer of observability, so we can trace all the requests of the user. And now let me show you how this application works. This implementation was done for a postal service company, and here you can see a few questions that I have already asked. But let's assume that you would like to send a package and you would like it to be delivered as soon as possible. So let's ask this question to the agent. Let's see which option they recommend. Here you can see that the agent recommends to choose the Express International option because the package will be delivered between 3 to 7 days. And this is amazing because our agent can retrieve information from one of our collections in our vector store database. All the answers that the agent provides to the user are based on internal company's policy. And this is great because the agent will provide their responses with the company internals documents. So it will not give you a random information from a different company. Let me show you how I built this. Here we have the end-to-end flow of our agentic workflow. It starts with a user request. In this case, it's what's your lost packages policy, and then this question will be sent to our agent. Our first LLM will serve as a router. We will use an LLM from OpenAI and we will trace all these requests in Langfuse. If you are enjoying this content so far, don't forget to subscribe to this channel because it helps me to create more content. Hit the like button below and turn on the notification bell so you never miss a new video. The main goal of this routing LLM is to classify the intent of this user request so it can send it to the right agent. So if the user request is about tracking a package, it will send it to this agent. But if the user would like to update their address or city, it will send it to this agent. And if the user would like to get information related to the shipping information or lost package policy, it will send it to this agent. In this case, since the user would like to know a bit more about the lost package policy, the router LLM will classify the intent as lost package policy. Here you can see that we have a shipping information and lost package policy in Qdrant, and this means that I have two different collections in my vector store database. In this case, I'm using Qdrant, which is super fast and can scale very well. So these collections that we have here contain information about the company's policy, whether it's from lost packages policy or shipping information. And this is exactly what we need because we want our agent to reply to the user with information of the company, not with random information from another company. And here you can see that as a next step, we will save the interactions between the user and the agent in PostgreSQL, so the agent can remember later on these previous interactions. Now we will send a response to our user. And since I'm running this app with my Docker Compose, we need to make sure that our application can interact with the Meta Developers API. So I'm using Ngrok to expose my local host to the internet. I'm gonna be creating a static domain and I will show you later on how I did it. And this static domain will be provided to the Meta Developers API. And with this, the response from my agent will be able to be sent to WhatsApp. And I'll be leaving in the link below the code for this repo. So let's check what we have here. So you can clone this repo. I'm using UV as a Python package manager because it's very fast. Then here you can install all the dependencies that I have set up in the TOML file. Then you will need to specify your environment variables because as I showed earlier, we're using Meta Developers API, Qdrant, PostgreSQL, OpenAI and Langfuse. So we'll need to specify the environment variables for each one of these tools. And then we can run this application with Docker Compose to spin up the PostgreSQL database and Qdrant. Both are run locally. And then we can execute these Python files so we can populate the databases. Here in CreateDB, we create a table for tracking packages and also the user's profile data and the interactions between the users and the LLM. So we create those three tables. You can see them here. One table for tracking packages, a table to update profiles data. So this will contain the user's profile data, and another table to store the interactions between the user and the agent. And then here we have the create vector store database. So we'll basically ingest the shipping information and the lost packages policy into different collections in Qdrant. and then you can start the FastAPI app like this, or you can just run the Docker Compose that also has a Docker image with the FastAPI app. Then we can use Ngrok to expose the local host to the internet. So let's check these steps in more details now. I'm going to assume that you already cloned the GitHub repo and then you activated the virtual environment and installed all the Python dependencies. So let's start with environment variables that we will need to specify. Since we're storing our SQL database in Postgres, we'll need to specify this Postgres user, Postgres password, and the Postgres database. Also, I'm using pgadmin to see the PostgreSQL tables. We will also need to specify the API key of the LLM that we will use. So in this case, it's OpenAI. And since we're using Qdrant as our vector store database, here I specify the link. And since I'm spinning this up locally, here I'm specifying the container name of Qdrant. So if I go to my Docker Compose, you will see that I have as a container name Qdrant local. So that's what I'm specifying here, Qdrant local, and then the port. Here I also specify the public key and the secret key of Langfuse because I'm using the cloud version of Langfuse, and then also I'm specifying here the host of Langfuse, and then here all these keys that you'll need to specify are related to the Meta Developers API. And I'm gonna show you how to create this app, and we'll also specify these credentials together. The first step will be to create a Meta Developers business account, and I'll be leaving in the description below all the links that you need. Since I already created my account, let's go to my apps, and here you can see all the apps that you have created, but in this case let's create a new one. You can click on create app, and then here let's call this app Postal Service YouTube V1. So let's create this app, let's click on next, then we'll need to specify others, click on next again, and then here we can click business, and that's it. We can click on create app, and here we can see a dashboard of our application. And since we want to integrate our agent with WhatsApp, we can click on WhatsApp setup. Here you can see that you'll receive a WhatsApp test phone number, and you can have a maximum of 5 numbers in which you can send messages. Here let's click on continue. If you go to app settings and then click on basic, you can check the app ID and also the secret. Here you can get the app ID. So if we go back to VS Code, we can specify in app ID, and then the app secret is the app secret that we had here. Let's paste it here, and here let's specify the phone number that will be receiving the messages. You need to specify here also the postal code, so have that into consideration. So if we go back to the Meta Developers API, let's click on WhatsApp here, and then let's go to API setup, and then here you can find phone number ID. So let's copy this out, let's bring it to VS Code, and then we can paste it here in phone ID. Now we'll need to specify the access token, the version of the WhatsApp API. So in this case, the latest version is the 22 version. So we can specify it here, and the access token we can request it here. So if we go back, we can generate an access token. Here we have the access token, let's specify it here, and then the last one that we need to fill is the verify token. So if we go to configuration, you will see here that we will need to provide a callback URL, which is the webhook of our FastAPI app that will be connected to WhatsApp, and then here a verify token. So we can specify as a verify token for this example 1, 2, 3, 4, 5, and then later on we'll specify the callback URL. So let's get this verify token, and then let's specify it here. And now that we have all our environment variables already created, we can proceed to populate the databases. So if we go to the data folder, you can see that it has 2 markdown files with the lost package policy and the shipping information that will be ingesting Qdrant. And here you can see the scripts. You can see the create database.py. Here you can basically see that we're creating package tracking table that will contain information of the tracking code and the status of the package, among other fields. Here you can also see information of the user's profile data containing information of the user ID, the name of the user, email, address, city, and so on. And then here at the end, we're creating a table to store the LLM interactions. So you have the ID of the interaction, question or the user request, and the response. So let's create these tables. So here in the terminal, you can execute the Python file, and then we can see that we have created package tracking table, the user table with 50 users, and the table with the LLM interactions. So if we go to pgadmin, we can see that these tables have been created. Here we have them, package tracking, user LLM interactions, and then the users. So if we would like to see, for instance, the first 100 rows, you can validate and click there. And now we can ingest our documents into our vector store database. So if we go back to VS Code, we can execute the create vdb.py file. And as you can see here, the files were already inserted into Qdrant. If we want to validate, we can go to Qdrant. Here we can see that we had 0 collections, but if we refresh the page, we can see that we have now 2 collections, which has text from the documents and their embeddings. So let's go back to VS Code. Now that we have populated populated our vector store database and our SQL database, we can check the application that we have. I have all the source code of our FastAPI app in the source folder, and then on core you can check the 𝗹𝗶𝗸𝗲. Here you can see the FastAPI. So we have this WhatsApp router. Here we have basically two functions, one function to handle the WhatsApp events and then another function to send the WhatsApp messages. So this handle WhatsApp events function has as a goal to receive the messages from WhatsApp that the user sends. So if you can see here, we'll get the sender ID, the phone number basically of the user who sends this message, and then here we have the content of the message. And then the content of this message will be sent to the LLM router, which will give the bot reply, and then with this other function send WhatsApp message, we will send to the user the reply from the agent. And now let's check this LLM router function so we can analyze the agentic workflow that I built. So you can see here that the first step will be to classify the user's input, whether it's for tracking packages, update user's data, or information related to shipping or lost packages. So if we check this route message request function, we can see that the first step will be to retrieve the last 5 interactions with the objective to know what has been talked between the user and the LLM earlier, so it can provide more accurate responses. Then we'll specify to the LLM that its goal will be to classify these requests between tracking packages, change user data, shipping guidance, and lost packages. Here we will also append information of the last 5 interactions, and here we'll specify the current question. Then we can proceed to call the LLM. We specify the model name, the messages, which is the conversation that I just showed, and then I have response format because I want to have structure output. For this I'm using a Pydantic class. Here we can see it's called message request type. Here you can see that I want to have the request type and it needs to be track packages, update users data, shipping guidance, and lost packages. And I also asked the LLM to give me a confidence score, how confident the LLM is of this request type, and also a description of the user's request. And this request type will allow me to get the intent of the user's request. So that's what I'm getting here. I'm parsing the result and saving the interaction between the user and the LLM. So if we go back to the LLM router, we can see that from the classify message, we want to know the request type, which is basically the intent. And if the intent is to track packages, our agent will run this function. Here you can see that in this function we get the last 5 interactions between the user and the LLM, and then we specify to the LLM that it needs to extract the tracking number that the user is providing. We'll specify the last 5 interactions, and here we specify to the LLM that we want a structure output, so it will provide the tracking code, a confidence score, and the description of the user's request. And now that we have the tracking code of the user's package, we can execute this SQL query. We will save the interaction to our database and then provide this response to the user with information about the tracking details, the last update, the status, the location, the shipping type. But if the tracking code that the user provided doesn't exist in our database, we will tell this to the user. So if we go back to the LLM router function, so we can see here that if the intent of the user request is to track packages, it will go through this path. But if the user would like to update their address, it will go through this path. So it's a similar SQL query, but in this case, instead of executing a select statement, we would like to do an update statement. But in this case, if the agent detects that the user's request intent is to get information about shipping or lost packages, it will go through this path. So let's check it on more detail, the retrieve policy and shipping info. Here you can see that I'm using a tools for function calling. So I'm gonna execute this function called search Qdrant, which I have below, and I would like to retrieve company policy from the correct Qdrant collection based on the user's query. And as we saw earlier, we have 2 Qdrant collections. So this tool will tell the LLM to analyze to which collection it should go and retrieve the information. Also, we'll retrieve the last 5 interactions to get a better context, and then here we'll specify that you are a helpful assistant that strictly follows company policies, because we don't want our LLM to give the company policy of another company. We want to strictly restrict our LLM to give information of our documents. Here we will append the last 5 interactions and also the current conversation, which is the user input or the user request. And then here we specify to the LLM the model that we want to use, the conversation, these messages, and the tools that I want to use. So the LLM will specify here to which collection to check. And that's the big advantage of using tools for function calling. So here the LLM will see if it needs to use one of the tools, which are retrieving information from Qdrant, and then here it parses the arguments of the tool, and then it searches in Qdrant, and then we retrieve from Qdrant the relevant information, which will be later on appended to the conversation history, because we will use a second LLM request. So you can see here that we will append all the messages, and we would like to have a final response from the LLM that will be sent to the end user. And then we will save the interactions to our database, and that's what we have with this LLM router function. And now that you have a better understanding at a high level how this agentic workflow works, let me show you how to completely integrate it into WhatsApp. If we go back to our end-to-end flow diagram, you can see that we are in this step. We have already the response from our agent and we want to send it to our user. Since this application is running locally with my Docker Compose, the problem here is that WhatsApp doesn't have access to our local host. So we need to expose our local host, and for this we will use Ngrok. So you will need to install Ngrok and also create a static domain, because that's what the Meta Developer API needs, and they will validate your Ngrok domain. So if you have a Mac, you can just do brew install Ngrok, and after you install Ngrok, you'll need to go to the Ngrok website, and then you'll need to configure your authentication token. So you just need to run this code in the terminal, and then you can proceed to create a domain. And here you can see my domain, my static domain basically. So if we go here and then we do start tunnel, you can see here the command that we need to execute in our terminal. So if we get to this command and then execute it in our terminal, we will be able to expose our local host with this domain. Here, let's execute this, but instead of 80, let's specify 8000, because that's the port of our FastAPI app. And here is the link that we will need to specify in the Meta Developers API. This is our webhook. So let's get this link and go back to the Meta Developers API, and then in the callback URL we'll need to specify this link and then specify webhook. After we do this, we'll need to do verify and save. But make sure that when you do it, your FastAPI app is running. And now here you will need to subscribe to messages. So if you scroll down, you will find the messages. You will need to subscribe, and now it's ready. Your agent is integrated through the Meta Developers API to WhatsApp. Also, something that I mentioned earlier on my workflow is that I'm using Langfuse to trace all the users' requests. So if we go here to Langfuse, you can see that I have here all the users' requests. Here you can see the users' request that I sent earlier, and then here you can see the information of the LLM. And that was it for this video. I hope this tutorial gave you a better understanding on how to build a production-ready AI agentic workflow where you are combining multiple tools, different databases like PostgreSQL, and also vector store databases like Qdrant, an LLM provider like OpenAI, and also using Langfuse to trace your request, adding a short-term memory in a table in PostgreSQL so the agent can have a better context when replying to a user, creating an application using FastAPI, and Dockerizing this application so it can be deployed in any cloud solution. But if you want to test it out locally, we can expose our local host through Ngrok by creating a static domain that can be linked to the Meta Developer API and therefore integrate our full agent to WhatsApp. If you like this type of content, please leave a like, and please leave in the comment section below if there's any use case that you would like me to address. And don't forget to hit the notification bell so you can be the first one to know when I upload a new video. See you next time.